Had a couple of kids ask about problem 1638. This is a KSP problem, and so what we have is cobalt hydroxide that's dissociating in water to make cobalt 3 plus and 3 hydroxide ions. Now, if we treated this just like a normal problem, we would have X and 3X, and so we would have X times 3X cubed equals the KSP. KSP in this case, 25, 10 to the negative 43rd. And if we solve this out for X, we would end up with 9.8, 10 to the negative 12th. And that could be our solubility, but there's a bit of a problem here. If we look at the concentration of OH minus, that would be equal to 3x. So 3 times 9.8, 10 to the negative 11th. Ooh, boy. Or, excuse me, 10 to the negative 12th. And that answer ends up being 2.9 times 10 to the negative 11th. That would be my concentration of hydroxide if all the hydroxide came from the cobalt hydroxide. Unfortunately, it doesn't. We've got this dissolved in water. And so what's going to happen instead is the cobalt hydroxide is going to dissociate to some extent. Cobalt 3 plus OH minus. Because we're dissolving this in water, we know that our concentration of OH minus from water is 1 times 10 to the negative 7th. That's 10,000 times more than what we're getting from the cobalt hydroxide. So we have to account for that. So actually it ends up being X and this plus 3X. Trust me, we're using 10 to the negative 43rd. X is going to be negligible, so we don't need to account for that. But what we do need to account for is now the KSP is going to be X times 1 times 10 to the negative 7th, and we still do need to cube that. We use that 3 twice, and so that's going to be equal to 2.5, 10 to the negative 43, and X in this case is going to be 2.5, 10 to the negative 22nd. See, the problem is the hydroxide isn't coming from the cobalt hydroxide. The hydroxide is coming from the water that we're dissolving it in, because cobalt hydroxide really doesn't dissociate very well. We wouldn't expect that from its solubility rules. That's how we get the answer that's in the book. I'm Smath. I hope this helped.